Lesson 4.5 is about sample size estimation. Remember, in the previous topics, sample size is given, and you need, given the sample size and the confidence level, the sample mean and the standard deviation, you need to solve for the point estimate and also for the interval estimate. In this lesson, the sample size is missing. Or another part of this lesson is the sample size is given, but the confidence level is missing. Let's start by reciting our memory verse. And today's memory verse is found in Romans 11, verse 25. It says, "For I do not want you, brothers and sisters, to be uninformed of this mystery, so that you will not be wise in your own estimation, that a partial hardening has happened to Israel until the fullness of the Gentiles has come in." At the end of this lesson, you'll be able to identify the length of a confidence interval. If you say length, what is the confidence level? That is the same as the length. Next, we need to compute for the length, or we say we need to compute for the confidence level. Then compute for an appropriate sample size. And the last is solve problems involving sample size determination. And here's your venture activity: the COVID-19 vaccine. It's very intriguing nowadays, but here's your problem. If people wanted to have a 99% confidence level of the results with a standard deviation of 0.01 and an accuracy within 0.001 error, how many people should be tested? Like, there are studies. For Pfizer, they got 1,000 sample size. For Sinovac, this size only. For Novavax, for AstraZeneca, what should be the sample size to say that the vaccine is okay? Now, what is sample size determination? If using sample size determination, we are asking, how large should a sample size be? For example, in your practical research one, you chose 10 as your sample size. Is it enough? It can be a main question. Or when you'll have a survey data, you'll survey 30 people. Let me ask you, is it enough? Or if you'll survey 100 people, is it enough? You see, this is talking about sample size determination. Why is it important? If you are surveying 1,000 people and 100 is already enough or large, then the 900 becomes a waste of resources. You see, if you have too many for the sample size, it will affect the time that you've got the data. It will also make an impact on the cost because you are reproducing many questionnaires, and it may lead to poor results. And if your sample size is too small, it will not also um, allow you to make conclusions. So we need to identify, what should the sample size be? What are some criteria for the quality of the sample size? First, confidence level. How confident do you want to be in your results? Is it 90%, 95%, 99%? And we say that the higher, the better. Second, narrowness of the interval. For example, you're asking, "Ma, how much should be my allowance for this month?" Which would you prefer? Your parents telling you 500 to 700, or your parents telling you 200 to 700? You see, In the narrowness of the interval, the narrower it is, the better. So here are two formulas for the sample size. If the given is mean, this one. If it is for proportion, you use these formula. What are these letters? N is the sample size. Z alpha over 2 is your critical value. Sigma is your standard deviation. E is for the error. If it's for proportion, P hat is the proportion that agrees to in favor. Q hat is the proportion that disagrees to or are not in favor. But if it's for proportion and the proportion is not given, then we assume that it's 0.5. What if the standard deviation is not given? If the standard deviation is not given, then we use this formula, R over 4. That's the range. It means the highest score minus the lowest score. Example, the highest is 20, the lowest is 10. So the range is 10. That's 20 minus 10. Let's have this problem. Problem number 1. Leonie wants to estimate the mean weight in kilograms of all 6-year-old children in a certain village to be included in the feeding program. She wants to be 99% confident that the estimate is accurate to within 0.06 kilograms. Suppose from a previous study, the standard deviation of the target population's weights was 0.5 kilograms. What should be the sample size? Now I mark it with a red are given. It's 99% confident. That is the confidence level. Then accurate to within 0.06. That is your error. Accurate to within. So our error is 0.06. And the standard deviation is 0.5. Remember, at 99% confidence level, our critical value is 2.58. Now, the problem talks about the mean weight. So we use this first formula. Let's solve. We have 2.58 times 0.5 divided by 0.06. You square, that's 462.25. And here's the rule for sample size determination. Always round up to the next number. Even if it's, you see, it could just be 462, right? But we always need to round up to the next number. Why do we need to round up? Here, the sample size tells us that we need to have 462.25 children. If we'll just say 462, if you round it down, then we will not arrive to the 99% confidence level. It might be it's only 98.5. So we always need to round up. Because when we round up to 463, we are assured that we come up with our confidence level. So we say the required sample size is 463 6-year-old children. Now, second problem, hourly wages. You know what I commonly do? I just highlight all the numbers. Example, 850. Okay, standard deviation, sigma. Next, estimated within 150. That is error. Then 95% confidence. That's the confidence level. So our by critical values are 1.96 plus and minus. This is talking about average hourly wages. So I'll use the first formula. Substituting that, I'll arrive with 123.35. I round it up, I'll have 124. Now, the next problem. In the next problem, Joshua wants to replicate a study where the lowest observed value is 12.4, while the highest is 12.8. He wants to estimate the population mean to within an error of 0.025 of its true value. Using a 99% confidence level, find the sample size that he needs. Now, this is the error. This is your confidence level. So our critical value is 2.58, but your standard deviation is missing. What's given is the lowest and the highest value. So that's the range, right? So we subtract them. 12.8 minus 12.4. That is 0.4. You divide it by 4. That's constant for the formula for standard deviation. Our sigma is 0.1. We substitute it. Our sample size is 107. Now let's go to the next type of problem. I leave problem 4 with you. And also problem number 5. If the confidence interval is missing, then we need to have this formula. For mean, this is the formula. For proportion, this is our formula. Example. Let me have problem number 6. DT-LT telephone company's data shows that length X of their international calls has a standard deviation of 14.5 minutes. The company wants to estimate the mean length of these calls within 5.5 minutes of the mean. With a sample size of 27, what should be the length of the confidence interval? Now, what's the given? I told you that my technique is I underline all the numbers. 14.5 minutes. That's the standard deviation. Next, 5.5 minutes. That is the mean length. Estimate of the mean length. So that is our error, 5.5. Sample size of 27. So what's missing? The length of the confidence interval. Or we say, what's the confidence level? Since this talks about mean, so we'll use the first formula, this one. We substitute. E is 5.5, square root of n, that's 27, all over sigma, that's 14.5. So we arrive with 1.97. Now, this is, with this one, you need to have your Z table with you. Let's open our Z table first. We need to check for the probability of 1.97. Here, 1.01234567. That's 4756. And in this data, we'll have two-tailed. So it means that you need to multiply the area 0.4756 times 2. So the answer is 95, here, 9512. With that one, we'll have 95%. Or we say that the confidence level should be 95%. Let's have the last problem. If you have questions, feel free to raise your hand. Detergent X. Now, Mary wants to know the proportion of households who like to use detergent X. A previous survey showed that, wait first. Yes, Abigail. You could unmute your microphone.
Ma'am, unsay ilanan nga kuan two-tailed ug one-tailed?
For chapter 4, let's have two-tailed for all. You'll encounter the difference in chapter 5, because in chapter 5 we'll really have the what's this, the verbs for one-tailed and for two-tailed.
Okay, ma'am. Thank you.
So again, let's have two-tailed for all of these problems. Now, a previous survey showed that 42% like to use detergent X. Now, here's your cue. It's 42%. So we're talking about proportion. So we use the second formula. Mary likes to be accurate within 2%. That's the error, 0.02. 42% is your P hat. So your Q hat is 1 minus P, right? If the sample size is 2,340, what should be the length of the confidence interval? So we have our sample size, and when we subtract P from 1, our Q is 0.58. We substitute it to this formula. Actually, the best way is to use a 4-line calculator. What's a 4-line calculator? Usually, it has this one. How is a 4-line calculator different from a 2-line calculator? In a 2-line calculator, you could not write this one in this form. But actually, you can do it. If you are using a 2-line calculator, you need to have a parenthesis. Let me screenshot it. But if you do not have any 4-line calculator, my suggestion is you use the online calculator. Here, if you're using a 2-line calculator, you need to have this in parentheses, this one in another parenthesis, and this one also. Okay? So that it will give you the correct answer immediately. Now, our Z alpha over 2 is 1.96. So we go to our appendix table, 1.96, that is 4,750. It's two-tailed for this lesson. So you multiply it by 2 here. The answer is still 0.95, or that is 95%. Now,